Okay, geometry, we're going to pick up with the second day of our notes here on section 1.2. Most of the time I'll just make this one big video file, but now for the beginning of the year, since we're trying to figure some things out, we're going to do it as two separate ones. So in the first part of these notes, we talked about the three undefined terms of geometry: points, lines, and planes. And in each one of those cases, we gave a definition for the term, even though it was technically undefined. We gave a description of how it was going to be named, and we also drew a diagram for each one. But before we move on, I do want to go just a little bit further and talk about kind of an old school method that can be used for naming both lines and planes that sometimes come up as well. And in fact, in the very next problems that we're about to do, we're going to see these. So we wrote down earlier that a line can be named right here by any 2 points that are located on the line. Or another way of doing this right here is that a line can also be named by a single lowercase cursive letter, or a script letter, if you want to look at it that way. So a single lowercase cursive letter can also be used to name a line. Now, it's important that you understand that if we're going to go this route for naming a line, that single lowercase cursive letter does not name a point on the line. So on this particular line that we drew here, we named it, 5 different ways here, although there were actually 20 different ways of naming it in that case. But the single lowercase cursive is usually written at one of the ends of the line, or by one of the arrows of the line, and we would write it here. So very often, letters in the middle of the alphabet tend to get used here. L for line, or M or N are the most common ones. So I'm going to put a cursive letter here, if I remember what my second grade teacher taught me, and what we have there, guys, is another way of naming this line here. Now, when you use it that way, there's no symbol that goes over the top, but it isn't a bad idea, although not necessary, to write the word line in front of it. But technically, just having M right there is good enough, because the only thing in geometry that we name with a single lowercase cursive letter is a line. So if you see that single lowercase cursive letter, you know that it has to be indicative of a line. But that said, it's certainly not a bad idea to write the word line in front of it. But we do not put the line symbol over the top. That's unnecessary here. So that is an alternative way of naming a line. And going along with that, there's an alternative way for naming a plane. We said earlier that a plane can be named by any 3 non-collinear points in the plane. Capital cursive letter, not lowercase this time, but a single capital cursive letter. And just like with lines, if we're going to use this method, it does not give the name of a point. They tend to just put it randomly somewhere, usually kind of in the corner of that parallelogram that you've drawn for your plane. And for no good reason, I guess I do know the reason, the letters that tend to get used most frequently here would be P for plane, and then an R or an S or something like that. So making a cursive P, we usually just make it something that's, big and a little bit flowy like that right there. As I said, R's get used a lot as well. So you could also call this plain P, just trying to make that clear that that's supposed to be a cursive letter and not just a regular uppercase one. So that method gets used as well. Now, I wanted to talk about those 2 ideas because with the problem that we're about to get into here, and I think you're going to see some like this on your homework from section 1.2, we're trying to give some alternate names for lines and planes here. So let's see what's going on. So within this diagram, we have a big plane here. And again, remember that a plane goes on forever, but we have to draw borders here even though they don't really exist. We have 2 lines that are intersecting within that plane. And we're supposed to give one alternative name for each of these 3 things. And the first thing they have for us here is line M. Now, unfortunately, you guys, I can't type in cursive because I really would have liked to do it that way and write it as line lowercase cursive m. So that's naming a line there using that method. And the other way that we talked about for naming a line is to name it by using any 2 points that are located on that line. So as we look at line We see we've got one point right here, which is A, and another point here, B. Both of those are on that line, so an alternative name we could use for line M would be line AB. So I'd put point A followed by point B, and in this method we have to remember to put the line symbol with arrows over the top. The only other way we could have named that is by reversing those two letters and calling it line BA. But the directions just said an alternative name, which means just one. We didn't have to list all of them. Okay, plane P. All right, now again, ideally that would have been a curve. And so as we look at plane P, we see that P located right here. It's down in the corner of a plane. So that's the kind of alternative way of naming it. We need to come up with another one. Well, the traditional way of naming a plane that we wrote down first was to use 3 non-collinear points that are in that plane. Well, as luck would have it for us, there appear to be 3 points listed in this diagram, and the question is, are they collinear or not? Well, it looks like points A right here and B and C do not all fall on the same line. Essentially, guys, if your 3 points form a triangle right there, if you extended that triangle forever in all directions, it would make a plane. So if you can make a triangle with 3 points, they are non-collinear, and that means that it's okay to name it that way. So we could also call this plane ABC, or CBA, or BCA. The order of those points does not matter at all. The only thing I would warn you about is that if I did put another point right down here somewhere and called that point D, you could everybody is because those 3 points, A and B and then point D right here, are collinear. They're all on the same line, and that does not work to define a unique plane. Think about trying to sit in a stool that had 3 legs, but all of those legs were collinear, all in line with one another, A, B, and D. That stool would topple over immediately. But if the 3 legs of the stool were non-collinear, such as A and B and C, you'd have some stability right there. So we couldn't do A, B, E because those 3 points are collinear. And the last one here, guys, they asked us to rename line L. Well, just like before, we would rename that line using 2 points that are located on that line, and we don't have a whole lot of options right there. It looks like on line L, B and C are the only points we could use there. So we could call that one line BC or line CB, and there we go. So that's a lot of what we're doing here in 1.2, just kind of learning about how naming figures is going to work out. Okay, a couple of key terms in geometry that we need to get definitions down for, and let's get working on this. Now, unfortunately, guys, I broke one of my own rules here. I've already been using a term here in this section that we haven't formally defined yet. So collinear points are going to be defined as 3 or more points that all fall on a common line. 3 or more points that all fall on a common line. So the easiest way to draw collinear points is to kind of look at it backwards and actually begin by drawing yourself a line. Don't forget arrows at the end here. And if we've drawn that line, and by the way, everybody, you're never going to hear me use the phrase straight line because it's implied that every line that we deal with in geometry is in fact straight. There is no such thing as a curved line. That's a curve. So if we've drawn a line right here, we can pick as many points as we want that are located along that line here. So I've got 5 of them here, and I'll call that V, W, X, X, Y, and Z. What we have right there is a series of 3 or more points that are all falling on the same line, so those 5 points would all be said to be collinear. The reason we draw a distinction between 3 or more, 1 or 2 isn't enough, is for this reason. if you have one point here, everybody, let me just call that point A, it would make no sense to say that point A was collinear, because there would need to be an end of that sentence. Point A would need to be collinear with two other points at a minimum right there. So there's no such thing as one point being collinear with itself. Doesn't make any sense. Likewise, we would never take the time to say that, for example, points A and V are collinear. And the reason why we wouldn't say that A and V, 2 points, are collinear is because by that rationale, 2 points would always be collinear. You can always draw a line between 2 points and V. That's one of the basic ideas of geometry that we'll talk about a little bit later on. So you can always draw a line through 2 points, so therefore that distinction is kind of meaningless. You can draw a line between A and W, A and X, A and Y, A and Z, but collinearity doesn't become important until you get 3 points. We would not be able to say here that A, V, and W, let me underline those, that A, V, and W would not be able to say that those 3 points are collinear, because you can't draw one line that contains all 3 of points A, V, and W. So let me get rid of some of that extra stuff that we drew there, and that's what we should probably have down. So break down the word, everybody. Collinear. Co means together, and then linear means line. Points that are together on the same line. And if you break it down that way, this next word starts to make some sense as well. Coplanar points are going to be points that all fall on a common plane. But this time we start with 4, everybody. So 4 or more all fall on a common plane. Okay, and to draw that one, I'm going to draw maybe a slightly different diagram than you guys had seen before. What I'm essentially going to try to draw here, you guys, is a folded piece of paper with part of it resting on the desk and then the other half of it pointing straight up in the air. So let's see what we can do here. I'm going to try to draw this as the fold in my paper and then kind of make it go back this way. See if you guys can follow what I did there. So here, ooh, drew that one too far. And right here. So hopefully you guys can see what I mean, that that's meant to indicate a folded piece of paper with part of that paper on the surface of your desk, and then the other part of the paper sticking up in the air somewhere, kind of looking something like that. Let me get rid of that shading right there. And what I want to do is just name a couple of points, actually more than that at random. I'm going to say that it's located up here. Point B is going to be right on the fold between those 2 points. Point C is also going to be on the fold, but in a different spot right here. And then point D is going to be located on the part of the paper that is resting on the surface of the desk. Okay? And what we should probably do then, everybody, is talk about a 4th point here as well, and I'm going to put point E right down here on that same piece of paper that's resting on the desk. So my question for you all is, with this particular diagram here, do we have an example of 4 or more points that all fall on a common plane? And the answer to that is yes. Our example of coplanar points here would be points B, C, D, and E. That right there is one group of coplanar points. All 4 of them fall on the plane now that is down on the surface of the desk. But you'll notice that we are not including point A in that group, because point A is not on the surface of the desk. Even if you extended that plane forever, point A is sticking up in the air above it. Now, if we wanted to, we could name another point on this vertical plane. We could call that F. And now all of a sudden, we've just created a second group of coplanar points. And that would be points A, B, C, and F. Those 4 points are all a part of the plane that is sticking up in the air. Now, this is not meant to confuse you guys here, but I do want to point out that points B, and C are present in both of these lists here, guys. And that's because B and C are located directly on the fold between these two planes, and that means that those points are parts of both planes together. Now, back to something else we talked about earlier. There's a reason that for coplanar points, we only talk about 4 or more points now. There's no such thing as 3 points being coplanar because all 3 points are going to be coplanar in the regard that you would be able to draw a plane that passes through any 3 of them. For example, if I were to choose at random here points A, B, and E. A, B, and E. So here's point A, here's point B, and here's point E. The question for you guys simply is, can we draw a triangle that passes through all 3 of those points, and using those as your vertices? And the answer to that is yes. Now you've just created a new and unique plane here that passes through those 3 points. But in the way that we have it drawn here, it looks like you can make a plane that contains A, B, and E, or I should say you definitely can make a plane that contains those. But it looks like that plane does not contain points F or C or D. It looks like all of those are a little bit behind that plane. So you've got to be careful in what you're trying to do here. Yes, technically A, B, and E all fall on the same plane, but we wouldn't call them coplanar because coplanar doesn't become important until you have 4 or more points. All right, everybody, I'm going to stop right there for right now. We'll come back and we'll finish up this section just a little bit later as we're coming through.